So now we will see an example on orthogonal vectors, how to find orthogonal null. And this is the model question paper which will appear in model question paper. This is model question paper problem. The problem is if u is this vector and vector u v and w is three vectors, show that u, v, w are pairwise orthogonal vectors and find orthonormal vectors u1, u, v1, w1 from the vectors given vectors u, v, w. Okay. First, we will find the pairwise. Show that u, v, w are pairwise orthogonal. Orthogonal means this inner product of two vectors. Pairwise means we take only two vectors, these two first and these two second and these two third. Pairwise orthogonal means we take two vectors. If we take u and v and their inner product is u v, inner product is u transpose dot v, dot product of u transpose and v, which is equals to u transpose is 1, 2, 2 and v is same as it given vector 2, -2, 1, which is equals to 1 into 2, 1 into 2, 2 plus minus 2 into minus 2, -4 plus 2 into 1 plus 2. 2 plus 2, 4, -4 gives 0. These two are pairwise orthogonal. U and V are orthogonal. Then we take U and W. Vectors U and W. U transpose dot W, which is equals to U transpose is same as 1, 2, 2 and W is the given vector 2, 1, -2, 2, 1, -2. Therefore, these two dot product means multiplication. Multiplication of these two vectors gives 1 into 2. 1 into 2, 2 and 2 into 2, 2 plus 2 into -2, -4 gives 0. Therefore, these two are also orthogonal. And we take U and W. U and W, U and V and U and W. We take U, V and W. V and W. The inner product of V and W is V transpose dot W. We get V transpose is V transpose, that product of V transpose and W is V transpose is the row vector. This is column vector. V transpose means row vector, row 2, -2, 1, and the W is 2, 1, -2, 2, 1, -2. The dot product or multiplication of these two vectors is 2 into 2, 4. And 2 into -1, 2 into 1 is -2 and 1 into -2 is -2, which is equals to 0. Therefore, U, V, W are pairwise orthogonal. Their inner product is 0. That's why we conclude those vectors are pairwise orthogonal. U and V are orthogonal to each other and V and W are orthogonal to each other and V and W are orthogonal to each other. Okay. From this, we conclude that the given vectors U and V, the given vectors U, V, W are pairwise orthogonal. Pairwise orthogonal vectors. Pairwise orthogonal vectors. Okay. Next we find the orthonormal vectors u1, v1, w1 from the vectors u, v, w. To find orthonormal vectors, we have one formula that is for u we have u cap which is equals to the vector u divided by the norm of u. For this, we need the norm of these three vectors. Okay, therefore we find the norm of these three vectors. Norm of u is root of sum of squares of each element. Sum of squares of each element. 1 square plus 2 square plus 2 square. 1 square plus 2 square plus 2 square gives 1 plus 4 plus 4 gives root 9, which is nothing but 3. Root 9 is nothing but 3. Okay. Next, find the norm of vector v. The norm of vector v is sum of squares of each element of that vector. 2 square minus 2 square plus 1. 2 square plus minus 2 square plus 1 square gives 2 square 4 minus 2 into minus 2 plus 2 plus minus 2 into minus 2 plus 4. 4 plus 4 8 plus 1 9 which is equals to 3. Similarly, norm of w is also same. Sum of squares of each element. 2 square plus 1 4 plus 1 5 plus 4 9 gives 9. 4 plus 1 plus 4 gives root 9 which is equals to 3. Therefore, the length of vector u is 3. Length, the norm is nothing but length of vector u. Here length of vector v. Here length of vector w. Okay, this is length of these three vectors. We have to find orthonormal vector from the given vectors. We have this formula: u cap is equal to vector u cap is equal to vector u divided by norm of u. This is equal to vector u is given by 1 2 2 1 2 and 2, and its norm is 3. Norm is nothing but length is 3. Then 3 goes inside the matrix. We get the orthonormal vector as 1 by 3, 2 by 3 and 2 by 3. One by 3, 2 by 3 and 2 by 3. 1 2 2. Okay, this is orthonormal vector of u. Orthonormal vector of u. Okay, we find the orthonormal vector for v is, we have the formula vector v divided by norm of v, which is equals to vector v is given by 2 minus 2 1. 2 minus 2 1 and norm is 3. Yes, norm of v is 3. Therefore, the 3 goes inside. We get 2 by 3 minus 2 by 3 and 1 by 3. 1 by 3. Okay, this is orthonormal vector for v. Okay, and orthonormal vector for w is vector w and norm of w is vector w is 2 1 minus 2. 2 1 minus 2 the w, and norm is 1 by 3 means by 3 gives 2 by 3 1 by 3 and minus 1 by 3. 2 by 3 1 by 3 minus 2 by 3. This is orthonormal vector vector for W, the given vector W. This is the problem. Okay. This is the problem of finding the orthonormal vectors from the given vectors using its length. Okay. This is a model question paper. This is appeared in model question paper. You should more concentrate on this problem. Okay. So now we will solve another problem on this. So now we will solve another problem on orthogonality. Example 2 is, which pairs are orthogonal among vectors v1, v2, v3, v4? v1, v2 are, v1 is 1, 2, minus 1, 1, v2 is 4, 0, 4, 0, v3 is 1, minus 1, minus 1, minus 1, v4 is 1, 1, 1, 1. These four are the given vectors. We have to find which pair are orthogonal. Which pairs of vectors are orthogonal? Orthogonal means we have to find their inner product. Their inner product which is denoted by this bracket v1, v2. v1 comma v2 or v1, v2, which is equals to inner product is nothing but the transpose of v1 and dot product with v2. v1 transpose v2 gives the inner product of v1 and v2, which is equals to v1 transpose is v1 transpose 1 2 minus 1 2 minus 2 1 1 2 minus 2 1, and the v2 vector is 4 0 4 0, same 4 0 4 0. If we multiply these two vectors, we get 1 into 4 4 plus 2 into 0 0 plus minus 2 into 4 minus 8 and 1 into 0 plus 0 gives minus 4 minus 8 plus 4 gives minus 4. Therefore v1 and v2 are not orthogonal. Vectors. Okay. First pair. And second pair, if you take v1 and v3, v1 with v2 and v1 with v3, the inner product of v1 v2 v3 gives inner product of gives the orthogonal of these two vectors is v1 transpose dot product with v3, which is equals to v1 is same as this 1 2 minus 2 1, and v3 is 1 minus 1 minus 1 minus 1 1 minus 1 minus 1 minus 1 gives 1 into 1 1 plus 2 into minus 1 minus 2 plus minus 2 into minus 1 gives plus 2, and 1 into minus 1 gives minus 1. Here minus 2 plus 2 and 1 minus 1, which is equals to 0. Therefore the inner product of these two vectors is 0. Therefore v1 and v3 are orthogonal vectors. Okay. Next pair is v1 with v4. The v1 and v4. To find v1 and v4 are orthogonal or not, we have to find its those inner product v1 and v4, which is equals to inner product is v1 transpose dot product with v4, which is equals to v1 transpose is 1 2 minus 2 1, and v4 is 1 1 1 1 1 1 1 1 1, which is equals to the multiplication of these two vectors gives 1 into 1 1 plus 2 into 1 2 plus minus 2 into 1 minus 2 plus 1 into 1 gives 1, which is equal to 1 2 plus 2 minus 2 cancels, and 1 plus 1 gives 2, which is equal to 2. Therefore V1 and V4 are not orthogonal. Not orthogonal vectors. Next page. So now another pair of vectors is fourth pair, which is equals to V1 V4 V1 V2 V1 with V3 V1 with V4 over that over, and V2 with V3. We take inner product with V2 V3, which is equals to V2 transpose dot product with V3 gives V2 transpose is 4040, that row 4040 into that V3 is 1 minus 1 minus 1 minus 1 1 minus 1 minus 1 minus 1. The multiplication of these two vectors give 4 into 1 4 plus 0 into minus 1 0 minus 4 into minus 1 4 plus 0 into minus 1 0. Therefore the 4 minus 1 get cancelled, which gives 0. Therefore V2 and V3 vector V2 and V3 are orthogonal. Why? Their inner product is equal to 0. Next pair is, fifth pair is V2 with V3 already over, and V2 with V4. V2 with V4, which is equals to V2 transpose dot product with V4, which gives V2 transpose is 4040 as a row. 4040, and V4 is 1111. 1111. The multiplication of these two vectors gives 4 into 1 4 plus 1 into 0 0 plus 4 into 1 4 plus 0 into 1 0, which gives 8. Therefore their inner product V2 and V4, the inner product of V2 and V4 are not equal to 0. Therefore we conclude that as V2 and V4 are not orthogonal vectors. Okay, understood? Next pair is sixth pair. Sixth pair is V2 with V4 got over, and V2 V3 got over, V2 V4 got over, and V3 V4. Inner product of V3 V4, which is equals to V3 transpose dot product with V4, which is equals to V3 transpose means this vector as a row. 1 minus 1 minus 1 minus 1 1 minus 1 minus 1 minus 1, and V4 is 1 1 1 1 1 1 1 1. The multiplication of these two vectors gives 1 1 1 into 1 1 minus 1 into 1 minus 1 minus 1 into 1 minus 1 minus 1 into 1 minus 1 1 plus 1 minus 1 get cancelled, and the answer is minus 2. Therefore that their inner product V2 and V4, inner product of V2 and V3 and V4 are not equal to 0, which is equals to minus 2. Therefore V3 and V4 are not orthogonal vectors. These are the all possible pairs of vectors and their orthogonality and inner product. Finally, we find which pairs of vectors are orthogonal among the vectors. These V1, V2 are not orthogonal. V1, V3 are orthogonal vectors. v1 v4 are not orthogonal, v2 v3 are orthogonal vectors, v2 v4 are not orthogonal vectors, and v3 v4 are also not orthogonal vectors. This is the problem. Okay, understood?